We might have more snow days next week. Who knows? Somebody said it might snow on Wednesday this week, wasn't it?
Mm-hmm. Wednesday, right? Thursday.
Yeah. So, all right. Let me get to my notes here. Let's just start out. I know you're doing the tooling U stuff. I know Casey's done with them all already. Now I'm hoping that he spent a little bit of time on them and didn't just fly through them and take the finals and take the final a bunch of times until he got them right. I know Casey wouldn't do that, but there are some that I feel like rubber stamp them and just go in there and as quick as you can get them done and answer them all, then answer them all again. And you do you, but you got to know there are going to be some quizzes. There's a midterm that's tied to tooling U, and there is a quarterly, like at the end of the since we're 2 weeks behind, it'll be like 2 weeks from today. We'll take a quiz over the first 5 modules. Okay, there's 18 total, but we will take our first quiz over the first 5 2 weeks from today. Okay, so I will let you use your resources on those quizzes, but you can't submit it and then look at what the answers were and then resubmit it, and you have a window of time to do it in. So just keep that in mind. When you're going through those, spend some time and look at the information. It still doesn't take that long to do them. I know that. I've had some dual credit instructors that have emailed me about snow days last week in e-learning, and you can see like how long, when you take one of those, they could see how long that they spent on them. And they're like, there's no way my students are only spending 5 minutes on this module and they're passing it. I said, well, that means that they're rushing through it. They're submitting it, looking at what they got wrong, and then they're doing it again. And then they looked at it and realized they were taking the final like 6 or 7 times, just trying to get 80% or better, rather than spending any time whatsoever looking at the content. So I want you to keep that in mind. I just had that. That's why I had to go back to my office, was to reply to that. Him and Natalie were talking. I wanted to jump in there. Okay, we're going to go through some notes up here. You're welcome to write them. You're welcome to type them. Whatever works for you. So for me, just seeing it and hearing it doesn't retain it. Okay, I've either got to be typing it out and following along, or I got to write it down. I know the idea of handwritten notes in this modern day doesn't fall on everybody. I was never that person. I had to type it and see it. Most of my notes are all typed out anyhow because my handwriting's so bad. ISNC. What does ISNC stand for? Hand up. Who's got the answer for me? That's what we're going to really be beating home in here. What's the NC stand for?
Pneumatic control.
Numerical control. Don't be pulling that pneumatic. Pneumatic starts with a P. I heard just because you said it. I heard our recruiter, one of our admissions recruiters out here, showing a high school class of machining students my lab, and I'm standing here and I could hear her out there, and she said, "This is the computer pneumatic control lab." And I thought to myself, man, I hope none of them students know that pneumatic starts with a P and that the real thing is computer numerical control, because that just looks bad on us. But IS is industry standard. Numeric control. Okay. The sheet I gave you's got 50 codes on it. Those are not the only 50 codes. As a matter of fact, there are lots and lots and lots and lots of codes. There are hundreds of them. Okay. There are custom codes that can be created. I give you guys all one of these books. If you already have one, now you've got 2. Pass those down. Pass those down. These are just little quick reference guides. These have the same codes that are on that sheet that I gave you in this book, okay? These are a great thing to keep in your toolbox to have on hand. It's got some different stuff that we'll look at in the book later that's got like formulas and things like that for some calculations that we're going to do. There's some stuff like things when you're out there at that control. It's got some things in there that are basically machine, walk-arounds or instructions kind of showing you touching off tools with the probe, clearing the tool and the spindle, some Herco stuff that helps out at the machine for somebody that's running that machine for the first time ever. So industry standard numeric control, I would say probably 75% of the codes that are on that paper I gave you transfer to any machine tool in the market, not just Herco. These are not just Herco codes that we're learning. When we speak numeric control, G&M code, we're learning something that we can take to any brand of machine tool and see what's happening, tell it what to do. Okay? I've said it probably to most of you before, it's all about navigation. I don't care if you're running a Herco, a Haas, a Mori, a DMG, a Mazak, whatever it is, 90% of the battle when you go from one tool machine to the other is just knowing where the screens are at and how to get through the menus. The parameters and the bulk of what you're doing is the same. It's just like if I walked out in the parking lot and I walked past my Chevrolet and I got into Mr. Wallace's new Dodge, I'm going to be trying to figure out, okay, where's the button? How do I work the radio in this thing? That's all it is. I know how to drive the truck. I just need to know where the switches are at to make everything turn on and do what I want it to do, right? That's all we're doing. Okay, we're learning how to be super universal when it comes to that, because some of you probably have been in shops that have multiple machine tools types, and some of you may have been in shops that they have literally one brand. They're like, this is what we use, we're going to stay, this is it. Most shops are not that way anymore. 10 years ago, it was very common to walk into a shop and they had like one type of machine tool. And that machine tool was white and red, and they basically flooded the market. And now, after the flooding of the market that Haas did, their service network did not keep up with them. So now it's very common to go in and see different machine tools in a lot of these shops that used to be Haas only shops. So I say that because I want you to understand that you're not going to, there's a good chance that better than half of you will go in a shop that they don't own a Herco. But there's a 100% chance you're going to walk in the shop and that machine they do have has work offsets, has a tool setup page, has G&M code logic that works just like this. Now the programming on the control might be a little bit different because they might have Mazatrol, Mazak's quick code, or visual quick code on a Haas, or on a Nakuma they've got the visual programming logic in there. The Fanics now have stuff on them. So we want to be industry standard when we come through here. Okay. All right. When it comes to G codes, I told you that the only thing I make you memorize is those G codes. Like, I'm going to quiz you what you took today on that assessment. I want you to get 50 out of 50 on that in May when we take the finals. There's a G&M code final. There is a program review tooling U final, and there is a actual program that you're going to write for me, all in 2 hours. Okay, you can do it. You will. By then, you're going to have so many resources and stuff to do it with. You'll probably be done in an hour and 15. Probably some of you earlier. I think the fastest I've ever seen it done with the passing grade, meaning they actually passed everything and didn't just, throw the Molotov cocktail on it, knew they were going to flunk anyhow, so they just rushed through it. I think I had somebody get it done in like 45 minutes one time. Blew my mind. And everything was right. Didn't cheat. Just listened all the way through and heard me say, make sure you're saving this stuff because you can use this as a resource later. Make sure you're keeping these files very organized because these are building blocks for you to build the whole thing later. All right, so keep that in mind as we build our thaw space folders. Keep the stuff organized because later you're going to go reference those, and it's going to do this when it comes to building your programs and saving you time on homework. If you've already got a 90% model to work off of, you can just come in and then fine-tune the little pieces that changed, add the other 10% to it. Okay, I don't want you to think that you have to reinvent the wheel all the way through, okay? G-codes. What are G-codes? Who knows what G-codes are? Now, if you've been doing the Tooling U modules already, you should be able to tell me what a G-code is. think. Especially, you've been through all of them. What is a G code? What type of code?
Time.
A G code is a preparatory code. Okay? Preparatory code. These are codes used to activate different cycles or movements on the machines. Not the physical movement, but the type of movement. It's telling it a type or a straight line, left turn, right turn, clockwise, counterclockwise is what they actually are. Drill a hole, tap a hole, bore a hole. You know, different cycles, what we would call G-code cycles. Work offsets. My origin for this part might be over here. That's work offset 1. Then I might have another part that I'm working on over here that's work offset 2. Those are different preparatory codes telling it which origin to use for the different parts. Okay, we're going to go through all of those in depth. The other part about these is they are what we call modal. Modal. That's this word right here. You'll hear this. That's a modal code. What that means is, in these controls or any CNC tool out there, if I load, I'm going to throw G54, work offset number 1 is G54. If G54 is in a program on a Friday and nobody loads a different work offset or sets it back to machine coordinates, G53, G54 is still going to be the XYZ0 on Monday until another work offset's called in. So they're modal until they're changed or something else is called that replaces them. When I say something else is called, it like something that takes its place. I can't have 2 work offsets active at the same time. The minute I type a G55 in, it switches to work offset 2. G56 work offset 3. G57 work offset 4. 58, 59, and then we get into all the auxiliary offsets as well. We've got 94 more of those that we can work on. Okay. Here, I've got my notes on one page and I'm just copying them over as we go here. Your M codes, miscellaneous codes. A lot of times people call them machine codes. They're technically miscellaneous codes, but what they do is they make machine functions happen. Turn the spindle on, shut the spindle off, stop. Turn the coolant on, turn the auger on, turn the air blast on, open the door if you have automatic doors, change the pallet out if you've got a pallet changing machine. Okay, all these different machine functions, they can be done. We could have it literally, I could set up a machine. Here's something that's happening right now. We're getting a new machine. It's a Takumi drill tap machine, which is Takumi's a partner, or not partner, is a company that Herco owns. Takumi's another OEM machine. Has anybody been to Herco and seen like the Takumis on the floor up there? I'd say you guys that did skills and stuff have seen it. Yeah. Takumi's literally like you go into the Herco warehouse, you walk through this garage door, and there's all these other brand machines sitting in this big area because Herco owns Takumi. And they sell them out of the Indianapolis warehouse in North America. They're a C-channel machine. They're a very heavy-duty, like die mold machine. But anyhow, we're getting one. We just cut the PO last week. I got to figure out rigging and get it shipped and everything. But the whole idea is next fall during our advanced class, we're going to have one of these collaborative robots in front of it. And we're going to set up an automation cell. And the students and I are going to build. Basically, we're going to take a 4-axis drill tap machine with a rotary in it, with a with a 3-axis machine with a rotary for the 4th axis, and we're going to set it up to do a 5-axis project using the fixturing that we have through 5th axis and Raptor, and letting the robot index the part in the machine so that we can do 5-axis work in a 4th axis setting. And then also we can walk away at night and let that thing run. But there's going to be a bunch of, the reason I'm going with that right now is the way you get that machine to do it is you use M codes telling the machine, okay, machine stop, park right here in this position, call the robot. It calls the robot, opens the door. Now the robot could open the door, or the door could be on an actuator and open itself with an M code. Then the robot comes in, and M code releases the vise or the fixture. Robot takes the part out of this vise, indexes the rotary, and these are all step by step. Don't think that this is like some big rocket science. It's like you do one step at a time. Build it in blocks, and then load the part, spin the part 360, and load it back in. And then start the cycle back up after the robot gets clear and finish up the other side work. We don't have to touch it. No human hands are going to be a part of that. It's going to be pretty cool to watch as like a demo, but let's say next year, and this is where my head is with this. Does anybody know the story behind these engine blocks? Okay. Here's the whole story. When I was a student here, there used to be one 5-axis machine that sat right here. It was a Haas trunnion machine, older, sat right here, and we were getting ready for the car show, and I was going around on GrabCAD just looking at stuff, and I saw a V8 engine block, and I decided when I was a student, not an instructor, I want to make one of those. So this was my 5-axis project when I was a student. Now, I don't. Actually, yeah, I do. It's in my office on the shelf. If you want to see the original one, it doesn't look near this clean. The original one I made. I didn't have any fancy fixturing. I didn't have any exciting tooling. I just had what we had, and we made it work. It took it 35 minutes to make one of these. Okay. During the car show, everybody wanted one, but we could only spit like 1.5 out per hour. So like we got like 10 of them out. Fast forward, 10 years later, I was a instructor. And we were running them out here during the car show. We kind of dialed it in. We got these down to where with the fixturing and everything we got, we can make them in like 10 minutes. Okay, we can pump them out pretty quick. David All, he was a student. He made the clock that used to be on the wall. It's sitting back there. I was going to put batteries in it and I forgot. He made that clock back there, but he shared it and tagged 1320 video in it. Does anybody know who 1320 is? Kind of a performance video. Yep. So he tagged them in it, and they messaged him and said, "Hey, how can we get some of those? We'd like to have that engine block. That's cool." Like the owner of 1320 video. They were like, I forget the guy's name, but they were talking back and forth. Well, then they shared it on their social media. Well, they've got like millions of followers online. I don't know what they've got now, but you guys, I'll tie this all together here in a second. $2.8 million followers. Okay, back then they had a little over 1 million. You know, this was almost 10 years ago. They shared our engine block, and then all of a sudden, we turned like we were in full sell messages. We want that. We want those. Where can I buy them? And we turned it into a scholarship fundraiser, and we sold like 2,300 engine blocks over the course of the next month and a half. Student volunteers running the machine. Okay, everybody got like, we had like it worked out to where like if you worked an hour, you got like $20 scholarship out of the foundation account. You had to run the machine for an hour, and for every hour you worked, we pushed scholarship dollars your way. But still, he had to be in front of the machine. Well, if I get this collaborative robot set up, does anybody have to be in front of that machine? No. So I talk about that when we talk about M codes and automation. I'm excited about having that be a part of our class because I think it's something you're all going to have to adapt to. is not just being a machinist, but also learning where is it better for me to have a intern operator running this machine for one shift, or is it better for me to have a $30,000 robot that could run it all day, every day, 7 days a week? $30,000 robot. Actually, let's go this route because this will tie me right into the next. Collaborative. Okay. You know, and you get up here, you get up to 85,000. But if that robot can run 2 shifts a day, 24/7, that's a lot of labor you're saving, don't you agree? Now, if I can tell my boss, hey, we just got this contract, and I'll repeat a lot of this stuff a lot because I want it to go here to you. We just got this contract, and we got to make 20,000 of these parts, and we can't get that high school kid to show up every day that we need him in here running that machine. Why don't we just get one of these robots? I learned a little bit. I learned enough to be dangerous in school, but I know I can figure it out to set up this thing to run itself, and then we can just let this thing do its thing and run this contract out with this robot. And then when that robot gets done with that one, you can put it on the next one. I say it a million times. If you're one of those people that robots are going to take my job, you're one of those people that just needs to keep flipping burgers. Because if a robot can do the job, you don't need it. All right? If a robot can do the job right, okay, let's just say it how it is. If the robot can do the redundant, repetitive job correctly, I don't think any of you want that. All right? You wouldn't be here if you did. If you were going to go do robotic work, you could do it right now. You don't need college. Okay? You don't need to be here. I can get you all an operator job yesterday that pays $15 to $18 an hour right now. You just let me know. I'll get you in there. As long as you show up every day and smile and just sit there and change those parts out. There's shops that would hire somebody. They're constantly looking for them. The problem is you're not going to go much above that pay grade. Okay. Just kind of how it is. So anyhow, we're getting that, but that was kind of the thing I was saying there with M codes. We're going to tell that robot to do all that stuff with M codes that we build into the control. And that's like when you look at this book, if you go to page probably 3 or 4 here, go to page 8, it's got the M table. And if you go to like M52, M53, M54 in this book, this is on page 9, I guess it is now. Those auxiliary outputs, those are codes that you can customize, telling it to send the signal to do this. Send the signal, you can customize those auxiliaries. So, all right, gang. We're going to take a quiz at the end of class. Not quite as intense as the one you just took, but it's going to have 5 codes on it. The safety line, or block, however you want to call it. Each line of code is in a program is considered a block. Okay? Each line of code in a program is considered a block. The machine doesn't care what order you write it in. Okay? The machine is not dyslexic. It doesn't read things left to right. It looks at one block as one whole unit of code. So no matter what order you put them in, it's going to do it. Now I will tell you this. I want you to put them in numerical order because it does for us, and the way our brains work, it works better to read it left to right. Has anybody ever seen like those little things where they mess up a bunch of letters in it, but your eyes, you know, your brain works and it can interpret it? You know, our brains work pretty good, but let's just keep it simple. I'm getting a little older. It takes me longer to troubleshoot whenever I walk down. Mr. Stevens and I have things that we don't teach the same. Both ways we teach it effectively are correct, but there's things we teach where we don't teach the same. So this is how, if you were programming with him, this is how he would have you write this safety block. G17, G20, G40, G49, G80. No spacing. No extra keystrokes. Because, and I know exactly where he learned it, the instructor that we had when him and I both came through here would beat that into our heads. Don't add extra keystrokes. Why?
More room for mess up.
Not necessarily. Because, and this is what it was, back when we were going through here, older machines had character limits on the programs. And every space is a character. Every time you hit the space bar, that's a character it would add in. So even though, like, looking at that, you know, you got to kind of split that up in your brain. It sure looks cleaner just with the space in there, doesn't it? It makes it kind of stand apart. But that's why, because I was talking about it in the earlier class. I've got a machine I run that's a Doosan machine with a FANUC control, and it's got 2 megabytes of memory. Okay? 2 megabytes. Not a gigabyte, megabytes. Like 20% of a gig, basically. 20% of 1 gig. Your cheapest thumb drive that you could possibly buy anywhere now has 40 to 50 times more memory than the whole machine does. And that machine is like this. A lot of times we have to drip feed it programs, meaning that we have to put the memory card in and let it feed off the memory card that's got like 4 gigabytes. And even the memory card, I had one opened earlier. Let me see if I still have it open here. It's an SD card. Actually, I forget what the actual name of it is. It's like a not the floppy. No, we're past floppy. So for about a 1.5 year window between floppy and USBs, they use these. Basically, they're like a zip disk. I think there they are. They look like this. They're like little. They're not floppies, but they're like a little. I don't know, like a 2x2 little disc that would plug in, and they had like little serial, like the little thing would slide over and had little serial ports that plugged into the thing. They didn't last long. They were real easy to break. That machine up there still has them. He's still running the machine on them. You have to have a drive converter to plug it into the computer to take programs from A to B. You have to actually plug a thing into the computer to even get the stuff to the disk. But that was like the in-between USBs and floppies.
I think we have one of those at work.
Probably could, very well could. They're just like these little miniature discs, but okay. So let's talk about these codes. These are the 5 I want you to know. These are the 5 that will be at the top of every program that you run, you operate. G17. Go ahead to the next page here. Is XY plane selection. Not plane, plane. Not plane like plane, like plane like plane. There we go. XY plane selection. We're telling it that machine, the table is an X and a Y workspace we're working in. For 3-axis milling, it'll always be a G17. 3-axis vertical milling, it'll always be a G17. Let me say that correctly. 3-axis vertical milling, G17 plane is going to be our plane. Your X-axis is your left to right. Your Y-axis is forward and backwards. Your Z-axis is your up and down spindle. So these are both the table moving left to right. Your Z-axis will be the spindle. Unless you're on a gantry style machine. On a gantry style machine, the table stays still and the spindle moves all over on the gantry that way. So what is, anybody seen this before? Okay, that's called the right hand rule. You will see me do that if I'm at the machine running parts. If I'm at the machine running parts, you will see me do this without a doubt. If I'm making an adjustment and I'm trying to think, and anytime you see me going like this, and I'm certain, then all of a sudden you're going to see me do this, and I'm usually squinting, my mouth's open because I'm weird whenever I'm thinking. I'm trying to think, which way do I need to go, because that thing's not cutting that right, so I need to make an adjustment. And I'll right hand rule. Okay. Typically I'm facing the machine so nobody gets confused and thinks I'm flipping them off or anything. But these are my positive directions. When I'm looking at the machine, facing it, my thumb is positive X, positive Y, positive Z. Okay. Typically the Z is not as much as trying to figure out left or right, which way do I need to go by looking at the table and knowing I need to move the part, whichever way it needs to go. The spindle on those isn't what's moving, the part is. So if I got to take more off the left side of the part, I need to go negative X to move it to the negative direction and further into the tool. Okay. So say always remember your right hand rule. What I like is I'll give you a quiz, and even on the midterm or the final, there will be a question. When you're standing in front of the CNC machining center, which way is it going when the table is moving forward away from you? And I'll see people sitting at their computer and they'll go, just like that. I was joking at the earlier class. About 5 or 6 years ago, I had a student that was here, and Connor went and got a tattoo. He got a micrometer tattooed on his arm one weekend. Everybody was giving him a hard time. And I remember it. We were out there, and he was still, in the first year, and we're out at the machine, and he's sitting there trying to, he's like, which way do I need to go? And he's sitting there, and I just laughingly said, sounds like you should have got your axis tattooed on those fingers so you knew which way is your positives. So do your right hand rule. And then, he got his hand up there. But, it was right after he got that micrometer tattooed on his forearm and everybody was still kind of busting him about it. But, okay. The other ones, G20, inch, coordinates. Setting the machine to inch. We're going to look at Winmax here in a little bit. The controls have no trouble running inch or metric. It's literally G20 or G21, which is the code you're going to have in a couple weeks, or next week actually. We'll talk about those a little more. But we run everything in inch. We're going to watch a funny little video here in a little bit just to kind of break things up about the Imperial system. Because all I know is inch. It's what I work in inches, but I will sit here and tell you that, does anybody work in any shops that run metric? Isn't metric so confusing? It is? It's all multiples of 10. The only problem is we don't use it all the time, right? But as far as the conversions go, it's super simple. 10 times this, 10 times, it's just multiples of 10. Easy peasy. Where inches, we get a little out there, on the inch one. 12 inches in a foot. 3 feet in a yard. You know, all the stuff that stacks up gets kind of crazy. But we laugh about it. The whole premise of it is when we were breaking away from Britain, we kept their imperial measurement system, and then somehow we had it in our minds that the entire world was going to convert to us, when in reality we're like one of a few countries that still use it. What is it? There's just 2 countries?
It's Britain and the U.S.
Just us? So, G40, cancel cutter comp. G49, cancel tool link. Okay. Like I said, everything's modal until you replace it or you cancel it, until you shut it off. If I was working on Monday afternoon at the end of the day and I had a 1/4 inch end mill in there and I had cutter comp called in for that 1/4 inch end mill, to get the 1/4 inch tool to the side of my part, how far does it have to be comped over from the center line for a 1/4 inch? An 1/8 inch, right? So let's say I come back in the next day and I'm like, okay, now I'm ready to hog this pocket out. I'm gonna load this 1 inch cutter in there, and I don't cancel that tool comp or call the tool comp for this tool. How's that gonna fare with my part? It's not, because when it shifts this over an 1/8 inch, it's still 7/8 of it, or well, it's still 3/8 of an inch too far into the part, right? And then we scrap the part. So that's why we cancel these, and that what it does is when we cancel the cutter comp, we're going to be able to see that kind of stuff in our graphics screen when we verify it, that it's not right, that we need to make sure we get the right stuff loaded in there. Because that's the other part I'm going to hammer home with you. You should draw everything in the digital graphics that we have available to us now before you hit the go button to cut it into the material. Okay, every machine out there and every computer in here has the verification graphics on it. You set your material up, you tell it what tools you're using, and once you plug all your stuff in, it will give you a 3D representation of the part if everything's right. Canceling tool length, same thing. I could have 20 tools in that machine out there. Not one of those tools, when it's in the spindle, is going to be the same exact length as another. It's just not happening. I don't care how close you try to get them, they're not going to be within a few tenths of a thousandth of each other. Now, if you use a height gauge and stuff, you might be able to get them close, but they're still going to be a little bit off. So we touch all these tools off. We want it to have the right tool length in there. If we don't, what can happen is I can have a tool in the spindle, and if it has the tool length for this tool, and then it goes to the next tool, and I don't call the right tool length in, and that next tool is 3 inches longer, how do you think that's going to go when it gets down to the part? Boom. I call the G49 and G43, which is tool length compensation, turning it on, those are the money codes, because those are the ones that can cost you a lot of money if you don't have them right. If you don't tell it, because that's the one where it's coming down at a rapid and it can blow that spindle and the whole thing up if you're not careful, right? So, and then G80, cancel can cycle. And they may say something a little different on your sheet than what I typed up here, but it's pretty much, it's the same thing. It's just the wording's a little different in mine. Can cycles, like G81's a drilling cycle. If I have a drill cycle active, it's just like anything else. It's active until it's canceled or replaced. And I go to the machine, and let's say I go out there and I'm not paying attention. I go like in my quick code, and I'm just typing in a little movement, and there's a G81 active, and let's say I type in, I want to move over to the center of my part, and I don't know that somebody had drilled a hole and didn't cancel it for some reason, which doesn't happen very often, but it can. And I move to the next XY location that I want it to go to see if something lines up. The machine will try to drill a hole in that spot right away. Like as soon as you give it another XY location, if that's active, it wants to put a hole at that new spot you just told it to go to. which is why we'll write lines of code like that. We'll write a drilled line, and it could look like this. A block example: G81, G98, X 0.5, Y 0.5, Z minus 0.5. I'm going to use numbers with a feed of 10 inches a minute. So that's going to put a hole at 5 or half inch over, half inch up. And then all I got to do from there is I can just say X1, X2, X3. Then it's going to go in a straight line to the right. It's going to go over another half inch, put another hole just the same. Then it's going to go over another inch, put another hole just the same. Then it's going to go over another inch, put another hole just the same. Okay, and we're not on can cycles yet, but just to give you the idea of how that works. We tell it what the drilled holes parameters are in the can cycle line, then we tell it all the locations where to put them. So that's our safety line. So that really should be down here with these. Okay, that's the first 5, and an important 5. All of our software has it's built into the software to automatically put that at the start of the programs. Most softwares by default do that in their post processors. If you get software that is not doing it, I would ask your representative to have that built into the post processor so that it puts a safety line at the top of the program. Don't leave anything for you to have to remember it. Let the automation do what automation does. Okay. Last year was the first year we did this, and this is year 2. And obviously, you guys got lab, and you're getting out there and you're setting stuff up. You're gonna make some parts. First, you're the first group in the first year CNC is doing that. We're speedballing a little bit, trying to make sure we get you some more time on those machines. That being said, up until 2 years ago, we would come in here and we would start writing longhand coded programs. Meaning we would sit here together and we would type programs out, start to finish longhand. It is important that you can read the G code. It is important you can identify it and troubleshoot it. Do I think any of you will actually go to industry and sit down and they're going to hand you a print and then you're just going to sit there and start pounding it all out, G and M code? No. And it took a while for me to get the old timers on my advisory committee to jump on board with this. I said, it's not important for me to teach them how many keystrokes per minute and have them type in this whole program. What I need them to be able to do is look at it, identify where the issues are, and make the modifications and change it and keep going. We're using CAM systems. Even Winmax, when we program, is what I would call a CAM system. It's called conversational programming, but that is a CAM system. We're taking coordinates and values, and then it's generating code to make a part. It does just the same thing as MasterCam. When we get all that, you're not going to see it until I show it to you, but it literally is generating a program in the background, and it's running at the machine. When you cut a part that you program conversationally, it's running G code in the background that you can't see. It does generate G code and run G code just the same. That being said, it's important you understand the structure of the program, which is where I'm going with that. The very start of a program is going to look like this. All programs are going to start with a percent syntax. And then it's followed by the 5-digit program number. The program number is basically, it'll look like this, like a capital or a percent sign, and then on the next block, a capital O with a 5-digit number, anything from 00001 up to 999,000, or 99,000 $999. There we go. Let's say that right. If you've when it comes to like a Haas machine, this doesn't apply to us out here on these, but like on a Haas machine, they've got a lot of like their quick code programs, the stuff that's kind of running in the background. They have them in what we call locked out variables, which are like the 9,000s or the 90,000 programs. They'll tell you don't number any of your programs on a Haas. And I had a student ask me this earlier, and otherwise I would never think about it because it's been so long since I ran a Haas. But you don't want to number anything in the 90,000s because those are kind of set aside and they're hidden in the background of the settings. So you want to stay away from those. But most machine tools you can use them, and maybe even on a Haas now. I just know that was something that back in the day you had to stay away from them. I personally have my own way of doing it, unless the shop tells me they want specific like serial numbers or program numbers to tie to the serial number of the part. I got one shop that they literally, that's whatever the last 5 digits of the part serial number are, that's what they want the program number to be. And then I've got another shop that he doesn't care, so I just use the date. So like for today, my program, if I was writing one for him, would be 02021. February 2nd, first program I did of the day. There's nothing scientific about it. Month, day, is it the first program, the second program, or the third program of the day? If I go to his shop and I happen to, maybe I worked there a year ago on the exact same date, and I open up the machine and I see there's a program with the same first 4 digits, I'll ask him, hey, do you want to keep that program on there? And if he says yes, then I go to 02022. Nothing scientific about it, just they've got to be unique. On a FANUC-based control, raise your hand if you don't know what I mean when I keep saying FANUC. Okay. Oh, man, everybody's... Make sure you kept your hands down. Okay. This is a FANUC control. This is what they look like. Roughly 50 to 65% of the global CNC controller installations on machine tools are FANUC controls. The new Takumi has a new FANUC control on it. Smart. Heck, let's just tell it. Just tell it to give it to me. It's getting deep. The Haas controls. Haas is a FANUC-based control. Do they have their own housing and everything looks like Haas? Yes. Is what's inside of it extremely FANUC-based? Yes. They use the FANUC boards, like literally like the guts of the Haas control, and it has their own appearance, all their stuff, but it operates just like a FANUC control. Our controls are a little bit different. Ours and a few other machine tool builders build their own controls. Ours is PC based. So every one of these machines, if you go around and open up the back of them, they've got a PC in them. So they run off the Windows platform, which is why we have the desktop software we have like we do, because it's a Windows based software. I cannot believe this thing's taking so long to give me a list. It's really digging in. But FANUC is the market share of CNC machine tool controls. So lots of different builders use them. Here we go. DN, Nakamura. How about Takumi? Smart. Cherry picked a couple that I know have FANUC controls. Yeah. So you could have like 15 different brands of machines in your shop, but they all have the same control on them. So the navigation's the same. Like I could have several different machines, but they could all have FANUC controls on them. Matt's shop, the one I'm talking about, he's got all of his machines except for his Akumas have Akuma controls on them, but all of his mills, he's got a Doosan, he's got a Makino, and he has an old lathe, European, I can't think of the name right now of it, Harrison, it's a Harrison, but they all have FANUC controls on them. So the navigation on them is all the same. So that's what they look like. And these look way newer than his. This is what our new one will probably look like. Other than that's off the lathe. Okay. But they all do that. They all read just the same like we see here. Okay. So what can you expect in here? Well, what you're going to expect is we will program things and we will write programs. We're going to use the Herco, obviously, software. We're going to write programs. I'm going to show you how we export the code. What does kind of suck a little bit about it is it actually takes the code and converts it to metric. So even when we write programs in Imperial, the machine's actually running it metric in the background. You can't see it at all. It's just happening in the background. But if you export out the code and you have it send it, it exports it out as what it's actually running in the background, which is kind of strange. But I do have a converter that we'll put out on Blackboard that we can convert. We'll convert the code back over to look at it. I say that because one of the things we will be doing a lot of in here is I will be giving you assignments where I say, okay, here's a page with 5 different drill cycles. I want you to look through here's what the drill cycle is supposed to do. You know, number 1 is supposed to do this. Is the code correct or what's wrong with it? And you're going to look at it and you're going to decide, does everything look right or is there something wrong with it? You know, you'll have options. A, B, C, D, looks good. And you're going to be troubleshooting like that. Okay? That's why it's going to be important that you can read the code. I'm not going to make you type any big long books. I'm going to have you programming and writing stuff conversationally so we can get some more throughput. Because one of the things that took us to eat this class up is us sitting in here, and nothing against anybody in here if you can't type well, but we'd get the couple people that are Mr. Wallace's. If you ever see Mr. Wallace on his computer, it's one button at a time, okay? And when we're trying to type out a whole program, you need to be able to get it going. So we're going to try to delay that a little bit, all right? I shouldn't take so many shots at Mr. Wallace. You guys tell him. It's okay. I don't care. He earns it. Okay. The end of the program ends with a %2. Just kind of keep that in mind. These are basically like the start and the end, and everything in between is what it's going to read. So it starts and ends with a % syntax. Or all right. We're gonna X out of this full screen mode. On your desktop, there is an icon that says Winmax Mill. Make sure you get the Winmax Mill. I want you to double click it once and then give it time to open. Winmax Mill. Make sure you pick the mill. Double click it once, give it time to open. So, same thing that's on the controls in here. I do want to show you, I prefer, and I would recommend this so you can see and visually it's not all real small, because it opens up and everything's like minimized or small. You know, I like to take it and I drag it up, and I'll usually put this on the left, and then I'll put my verification on the right, which is this screen here. We're not going to do much with that today, but those both need to be open. If you close one, it will close the other. So if you accidentally X out of one, it's going to shut Winmax down. You'll have to let it finish up its shutdown, and then you'll have to reopen it. But we're going to look at the Winmax mill here. This has been a blessing since we started with Herco. I kind of talked about it a little bit. You know, we've had the Hercos here for 13 years now. 2000, well, yeah, in 2013 is when we had our first round of machines. Was kind of the thing I was talking about. We had all Haas. We had 3 or 4 machines that were down. We couldn't get any service. I remember it back then, like we were trying to have class and we had machines just down, and we couldn't get anybody to come look at them. And then one day, the salesman from Herco just randomly came through and cold called us, was talking to the dean, and then the next thing I knew, we were told, hey, we're buying $1.8 million worth of CNCs and we're switching brands. I can tell you that, like, when it happened, I was very skeptical. No bones about it. Like, everywhere I'd been at that point, everybody was running Haas machines. Everybody was buying Haas. Everybody had Haas. Why are we switching out? In 2006, so, you know, back before some of you were born, or most of you were born, in 2006, we were one of like 5 H-Techs in the country. Haas Technical Education Centers. Well, when we were one of 5, we got treated like kings. But then when we were one of like 500, it got really hard to get help and get, you know, assistance. They still gave us some scholarship money, and I know some of you came from high schools where they give them like $1,500 and this, that, and the other. They still do a lot of philanthropy and stuff, but philanthropy does not fix the machines. So we couldn't get any service. So that was when Herco came in. They're like, hey, we're in Indy, we'll take care of you guys, and they've done great ever since. Hence where we have this partnership. But one of the blessings in disguise that I didn't know was going to happen was this. All right? There is no good desktop software for other machine tools. Like, there's like what they call emulator software. Basically like simulation that kind of looks like it, but it's kind of not, and it's definitely not apples to apples. This is apples to apples, exactly what you're going to have out there. So when we do stuff in here and we click and we navigate, you can do it out there just the same. The only difference is, like this toolbar up here with these buttons, that toolbar represents the hard keys on the control. So those buttons up there aren't on the control up there, but they can be if you want them. If you're at the control and you double click down here in one of these boxes, I forget which one it is. Well, I think you have to take this off first. But you can actually add that to where that bar's up there with touch buttons too. But those buttons are all on the control, so we don't have it on there right now. So like, for instance, input, home. Okay, the little home means home. That's the input screen. That's the big button right here on the control. If you get lost, you can't figure out where you're going, go back home. Start from home. Go to the input button. That'll get you back to that main screen. You can start navigating back to where you want to go from there. Okay. Let's jump over here to Program Manager real quick. Let's all, everybody do this with me. This would be where all of the open programs that are in the control are. Now, a lot of times you can have a lot of programs saved in this memory that aren't even open right now on the control. You know, they're over in the folders and they're hidden. Typically, I don't like to keep a whole lot of extra stuff open if I'm not utilizing it in real time. Meaning it's not going to get ran anytime soon. I'm going to save that and close it. That way it's not cluttering up my manager here and showing this. This kind of goes back to like what I was talking about with robotics. Pallet changing machines are another automation. I could have a Tombstone's palletized system with 15 different parts lined up, and then in here I could have each one of the programs lined up and literally telling it, okay, when you finish this one, move to this one and then load this tombstone for the material and start this part. Who in here has been to Flying S before? Anybody been to Flying S? You been over Flying S? No? Nobody? Oh man, we're gonna have to get you guys over there. You've never been there?
I'm gonna get an internship with Peter Bowman.
Okay. I was gonna say, I think your dad used to work over there, didn't he? That's what I thought. I thought at one point he was there. Okay. This is how Flying S runs one shift. This is how this aerospace manufacturing facility out in the middle of the sticks in Palestine, Illinois, runs one shift, but turns out 3 shifts worth of work. Their machine shop has these guys in it. Oop, let's go back to that. I wish it'd stay on that photo. See if I can get it to just open that image. Okay. It's got these Matsuras in it that have pallets. You can see the pallets right here in line feed into this machine. With that, you can see that chunk of aluminum right there. That's one chunk of aluminum for scale. There you see the operator. Oh, I think that's Kendall Rubel. He's a graduate of the program. Okay. And they will set that machine up, and those things run literally, their spindle on time is like 88%. 88% spindle on time. When we talk about machines, spindle on time is figured on a 24/7 calendar. 84%, 88, 84, 84%, it's over 80%. I don't want to lie and tell you the wrong number, but it's over 80% of the time these machines are running, making parts. These guys work. They have what I call a flex schedule. You do 4/10s, or you can do 5/8s, and you can go any time between 6 and 6 is what your hours are. So like if you're a morning person, you can go in at 6 a.m. You can be done at 4. All right, do your 10-hour day, 4 days a week. Like they let you set your schedule up, and as long as you tell them this is my calendar, they work with you. It's a pretty cool thing they do, and I'm sure there's more to it than that, but it's pretty neat. But at 6 o'clock, from 6 p until 6 a the next day, they're still making parts using robotics like this, palletized systems, and automation. Pretty neat. It's a pretty big mill they've got there. I think that's an interesting one too. I like to look at this one because it's fun to go on here and say, okay, He graduated from here. 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 There's those other goofballs. Where's Caleb at? I got one guy I'm looking for, old Seawag. He graduated from here. He must not have been there on picture day. I don't see him anywhere. Oh, there he is right there. He graduated from here. All right. In 2012, this shop had, I think, 8 employees. It's 2026. This photo's probably been on there for a couple of years. You can see that they've got a few more employees now. But they still only run one shift. But they make parts 80% of the hours of the day, every day, 7 days a week, not 5 days a week. So, all right, they do that with automation. These controls, the Herco control has 2 different sides to it, not like a left and a right side. It's got what we call a conversational and NC side, meaning the conversational side, which is what we're going to be doing a lot of programming on. We're going to use what they call data blocks, so visual blocks as we're building milling, drilling, facing, pocketing, different tool paths. Just like if we use Mastercam or tool pathing, we're going to build data blocks to build programs to cut parts. Then it also has the NC side, which is the side I'm on right now. So if you aren't, go ahead and hit new with me. And I'd like you to pick the NC program right here, and it'll probably open up another one if there is not one already. That's fine. Did anybody else have HWM there? Yours did? Yours did? I wonder if those computers have been restarted, or I might need to check those 2 out. They did this morning too, but they could have just been left on still. So, were they on when you came in here?
I can turn it on.
You did have to turn it on? Okay, they probably need to. I probably need to thaw them and change that then, so it doesn't default to it. All right. When you double click that, you'll see it takes you to this page where you can type a G-code program. So I can type a %, you can type with me, capital O 02021, tell it test program, and then I can type in my G17, G20, G40, G49, G80. All right. So here I can literally load a program from another software like Mastercam in on the NC side, or because they'll come in, a Mastercam program comes in as code, it gets exported out of Mastercam or post-processed out of Mastercam as code, or I can write a conversational program using the built-in programming logic in the Herco control. But here's what I like about this. I want you to just take your cursor and watch down here when I move my cursor like onto the program number. Down here it tells me program identification number. Watch what happens when I put it in the G17. XY plane selection. Inch input. Cancel cutter comp. Cancel tool length. Can cycle. Fixed can cycle. Cancel. Okay. It tells me what the codes are. So when I'm at the machine, I'm trying to troubleshoot something. If it's not one of those codes that I'm super comfortable with or know exactly what it is, if I put the cursor in it, it should tell me what's that code supposed to be doing. And if it says it's supposed to be doing, let's say I've got a part. Okay. I've got a part and I'm in this line of code. And when I get to the machine, it's going like this, but it's supposed to be going like this, turning left. Well, when I look at the code, and this is one you're going to know, and I look at it and I see, okay, G3, circular interpolation clockwise, counterclockwise, that's what's making it turn right. but I want it to go left. I can fix the code and change it, and super simple example there, but it's nice. This control is pretty intuitive. It's got a help menu that's super powerful. It's got all kinds of stuff. If I'm programming and I'm here and I go up and I hit this help button, it opens up this help menu, and I can literally say, hey, I'm working on a G2, and I can get some programming examples to go and reference to see how it works. If you had enough time, you could sit here and teach yourself to program CNC yourself. It'd probably be a little quicker if you let me lead you, but you could literally teach yourself if you had to. Okay. Or if you're just like, hey, let me see the whole list. ISNC. And I can come down here and pick my preparatory G codes. It'll give me the whole list in my help menu of all these different G codes. Let's say I saw a G53 in the program. I didn't know what it was. G53. What is a G53 doing? Machine coordinate. What's that mean? This machine coordinate command moves the tool to the XYZ machine coordinate position at rapid traverse. This command is only effective in a block in which it is specified and is absolute mode. Meaning it's going to go to the wherever. When you fired up those machines the other day, you homed them out, right? It hits the hard stops. That's machine mode 000. And any value you put with a G53 is going to go from that location. Okay. Don't sleep on the help menu. There will never be a time where if I've got you working on a program, or the only time you can't use the help menu on Winmax is if I'm giving you a G&M code quiz. You will learn the G&M codes and you will memorize them. Okay? But if you're working through a program and you're trying to figure something out, don't sleep on it. Utilize it. Okay. The other thing I like to look at, let's go to the next icon here, take it to the tool setup page. Let's pick an end mill. Let's just tell it it's a 1/2 inch and tell it it's 4.5 inches long. To get it to take the values, you have to hit the enter key. Okay. So now it knows this tool's a 1/2 inch diameter and it knows it's 4.5 inches long. And I can tell it the RPM that tool should run at. I can tell it all this stuff, and we're going to do this. We're going to build a tool library with the tools that we're going to use to program most of our parts, to where you can come in and you can just load in your tool library and all this stuff's already there, so that you don't have to do it manually each time. Okay, we're going to set up a file, a configuration file, that will basically take all the program parameters, all the tool library stuff, and everything's going to load in when you get in here. That way you don't have to go through and like remember to, what do I need to check, what do I need to click, like all the defaults. Same thing you can take to the machine to load all your defaults in. Okay, we're going to build that next time. The other thing I think is neat is I talked about like the conversions. Notice at the bottom where it says inch, click that. It's going to say, hey, do you want to switch to metric? If you say yes, watch what happens to your values. It converts them over to metric millimeters. Perfect conversion. If you don't know the conversion to, oops. Let's say I've got 5 inches here and I need to know what that is in metric, but I don't know the conversion. Just hit the button here and it'll convert it for me. Machining guys, if I want to convert that, if I didn't have this and I want to convert 5 inches to millimeters, what do? 25.4. I take it times 25.4. And if I go the other way, I take whatever it is in metric divide that into 25.4. So if I have 30 millimeters, I want to know what that is in inches. I divide that by 25.4 and I get my inch value. But it's way easier just to click the little thing at the bottom of the screen. Let it do it for you. Okay. All right. So that's kind of nice. This is where, like when we have the tool, we're going to set those tool links. I know you're doing this already, or you started on it the other day. This is where we set those tool links, and it knows the different lengths of tools sticking out of the spindle, so nothing crashes. If I'm getting ready to run a program and I'm going into my tool setup and I see that that's 0, I probably know that I need to set something up still. So I do want to make sure you understand this. Notice that we've got tool 1 here, right? Watch when I go to my program manager. If I go to this other NC program, which is a blank program, but I go to tool setup, tool 1's still there. What I got to be careful of is if I go here and I go new, and I'm going to do a conversational program, okay? I got to be careful because it will, if the conversational program is like opening one, it will lose the tools. Because I didn't have any tools in a new program, so like, let me do something real quick here. Just to show you what I mean, because I want you to be aware of this. Don't know why. Save that. Okay. I'm going to say tool 1 on this is a face mill, and I'm going to say that it's 4-inch diameter and 6 inches long. I'm going to save that. Okay. Jump back over here. I'm going to change tool 1 on this one back to an end mill and 0.5 and 4.5. Okay. I'm just going to close all these for a second. All right. If I open up that no name file again, okay, you saw me change it to the different diameter and the different length, right? But when I loaded it in, did it keep that? So you got to be careful, because what you're going to want to do is you're going to want to set stuff up in here, and if you don't take your configuration out there with you, you'll lose all that stuff that you might have already built in here. Okay, and I'm going to show you how to do that. It's not like figure it out. It's literally we're going to go in and we're going to save, and it actually should be defaulting it, which is why I think I need to look at you guys' computer. Okay, because it should, whenever I save my program, I'll put this in the same spot. Yeah, it is. It's saving it, like automatically it's saving it. The NCSX file that you see right there on my thing that just popped in there, that's the config file with all my setup stuff. I want to make sure I take that to the machine with me as well if I'm going to run the part. Okay. Things that I'm pointing out, but we'll get in more into those woods whenever the time comes. Between now and then, you'll forget it 6 times. Okay. All right, but just be aware, FNC, that's the numeric control side. This is the conversational side. Notice whenever I'm in the conversational side, this menu looks like this with different milling options. When I'm on the NC side, it looks like this, where I can type longhand code in here or load in an NC program from another software. Let me see if I can go into my archive here. 25. Just loaded this part in. Probably should be able to draw it. I'd say it loaded everything in. Yep. Okay, I just loaded this old program in here. All right. Notice what it looks like. Now I wanted you to see this. I'm going to switch this. This is all in inches. So if I go into the programming for this part, this is all inch values for this little pocket thing going on. If I go here, I said I want to save as. And I'm going to save it as an FNC program. I'm actually not going to put it in that. I'm going to put it up here. Export. Okay. All right. Now go back and I'm going to open that. The one I just did. See if I can get it to do it. Exporting NC while NC data reserved, you may lose support. No. Okay. Air, machine on planes, retract tool. Yeah. Go ahead. Where's that thing going? Save as. Where it's going. I'll have to work on that, figure out why that's not working. Usually you export that as an NC file, and that's where you get to see that metric program. That's what I want to show you. Something's not working right now, so I'm not going to get too much further into that. Okay, let's look at these one more time. G17, what is it? XY plane selection. Everybody better be paying attention right now. Okay. G20. Inch coordinate. We're going to get inch coordinates. Okay. G40. Cancel cutter comp. G49. Tooling cancel. And G80. Cancel that can cycle. Okay. Put everything away. Put everything away. Close out or minimize any other windows on your computer. And I want you to open up Blackboard. Minimize it. You don't have to close it. Just minimize it. And I've got way too many windows open right now. Holy cow. As soon as I find my Blackboard, I'm going to turn the quiz on for you. Under the homework test and quizzes, there's a G&M code folder, and here in a couple seconds there's going to be a thing pop up. Okay, G&M code quiz number 1 should be open. quizzes. There's another folder. Genome code quizzes. Yep. Okay, gang. So, on Blackboard, right under where we were just at, there is a section called Genome Code Home Quizzes. You have 12, I think there's only 12 that you'll have visible, 12 Genome Code Home Quizzes that you need to take for points. They're worth 5 points each. You have to take them or you'll get a 0 on them. I guess you don't have to take them. It's just like anything else. You can take them as many times as you need to get the full grade. My recommendation is this. You take it once without your sheet out. You take it a second time with your sheet out and make sure you get them all right so you get all the points. And then you work it into where you take them before we come into class each day. Okay, there's 12 of them, so it's free 60 points. There's no reason you should not get all 60, but it's going to make you go through the list and practice them a little more. So there's some points tied to them. If you don't do all 12 of them, then you get 0 on them when it comes time to put the grades in, right? Everybody understands what I mean by that. Okay, I'm not going to get on there and check and make sure you're doing them. When the grade time comes, I'm going to check the box that says anything that there's no submission for becomes a 0. So don't look at that little guy over on the left-hand side when you get all your tool and use stuff done and think that it says A and you've got everything done. If you haven't done those, prepare for a 60-point hit whenever I click the button that says calculate these in. Because that's something I don't want to do on the front end. I'm already kind of, I don't want to show everybody's grades up here, but everybody shows F's right now because I just added the tool and use stuff in and nobody has all the tool and use, so it's making your grades look, I got to fix that. Don't let that freak you out. It's because it's calculating what you've done so far out of the full 180, which is your midterm tool and use amount. So I've got to go in and make a change to how it does that. Okay. The lowest 2 G&M code quizzes get dropped of the day, the ones we do together in person. From today forward, we will take 2 per day, one at the beginning of class and one at the end. Okay, so be ready for a front end and a back end G&M code quiz. We'll take those every Monday. Every Monday. And if Sipes decides he wants to give you guys some quizzes and stuff in his section with you too, you might get one on a Wednesday. Okay.
Isn't it Stevens?
You guys have Stevens? Okay, your afternoon. Yeah, Stevens. Sorry. I think about you guys being morning out there, and then Sipes. Yeah, sorry. Yeah, you're with me in the afternoon, so you'll have Stevens. Okay. All right. The other thing tied into this. In 2 weeks, we will take a quiz, a tool and use quiz. That will be over everything through 220 right here, week 4. Okay, this is week 4, but we're a little behind and stuff, and I get that. Get caught up, get those done, go through them. It'll be over basically those first 5 modules on tool and use. So if you're not sure what order to do them in, if you come on here, you can look. Remember on those 2, you can retake them if you didn't like the grade you got. Like I said earlier, don't just sit there and take the final a bunch of times trying to get it to where you can pass it. You know, you might have to look up some of the answers, but I'm just going to tell you that it's probably better that you look up the answers and you get them right than you just submit, and just keep changing answers and not knowing, because when you take the quiz and there is a time window you're stuck in, kind of knowing where to go find the stuff might be helpful too. Okay, not kind of, like it will be helpful, because you do get to go look at the resources and help find the answers just like you would if you were out in the real world doing it. Okay. All right. Questions about that? Most of you in here have plenty of tool and use stuff that you need to get caught up on. Like all of you that, when I look at the grade, have a 0 right now. I would stick around here and I would work on those. I know some of you were working on earlier. I haven't clicked in here to see where we're at by this group. Well, I guess I can't tell because I had to bring the tool and use. What I have to do with that is, so when you finish it on tool and use, don't go to Blackboard and look at it and be like, something's wrong. I have to manually pull them over. So like when you finish them on tool and use, I have to export the gradebook and then plug them back in each time. So when you get them done, probably once a week, probably on Monday mornings, I will export the gradebooks off tool and use, and I will update the gradebook on Blackboard for you. You have to get 180 points to get full credit for tool and use by midterm, which is week 8. We're week 4 right now. So week 8, you got to have at least half of them done. If you have like over half of them done, it probably will bring you over the 180 point mark, and you'll get the full credit for 180 out of 180 for midterm. But that does not operate that way at the end. When we get to the end, it's 360 points. There's 18 modules that are worth 20 points each. There's 360 points, and whatever you got on the modules will be the grade. So you can like do 2 extra modules and get the full credit for the midterm grade. Does that make sense to everybody? But when you get to the end, it's going to be whatever you have out of 360 is what you get. Okay? So you got 60 points in Gene M Code home quizzes. You're going to be taking those Gene M Code quizzes every day, 2 a day. Unless it's like it's jumping to stuff we just covered. Like we're going to cover on next Monday, we're going to talk about the next 2 weeks of Gene M Codes. So down here in the study guide materials, in the weekly edition list, if you want to study ahead a little bit, weeks 2 and 3, I'm going to give those all to you next week. We're going to go through them all. You got to play a little catch up, and if you're really feeling froggy and you want to go ahead and look at week 4, you can go ahead and look at week 4 because we're going to double up again after that. Now, will you see them all right away on a quiz? No. The quizzes will never have more than 4 or 10 on them at a time, other than the midterm and final now, and the assessment quiz you took today. That's the only times you'll see all 50 of them at once. Any questions? Okay. It may seem like a lot. Just try to front end load and take small bites daily. Don't try to just do it all one day a week and then forget about it. Try to make sure you're keeping up with these Gene M codes. Learn them. I don't hold any bones about it. I bet if I really looked hard in one of my old toolboxes from school, I'll bet I could find them. I could not learn the Gene M codes. I was mid-20s whenever I came back to school to do CNC. Was working in a manual machining shop and decided they bought a CNC and I loved it. I wanted to learn how to program it. Came back to VU in my mid-20s, got my education. I could not learn the Gene M codes for anything. I had to humble my mid-20 self to make flashcards and start practicing them every chance I got. Every chance I could sit down, I'd practice them. And I laugh now. I've got 2 7-year-old twin, probably gonna be my stepdaughters one day, and I sit with them and I'm working through their class words using flashcard. Yeah, just like that. I'm sitting there working through their words that they're trying to learn how to this, they, going through all their words, and I think about myself. G43, tool length compensation. G54, work offset number 1. G80, cancel can cycle. G84, tap cycle. M8, flood coolant. M9, cooling off. M3, spindle on clockwise. Never did I think that I'd be like I am today, where I can literally 90% of the codes you can put in front of me, and I'm gonna be able to tell you what it is, or supposed to be by the default list. I've got it. It took me a while. It's the only other language I speak. I speak just enough Spanish to get in trouble. I took 3 years of it. Never got good at it. Okay? I'll never figure out how I have 3 years of foreign language in school and I got an A all the way through all 3 years, and I couldn't even say a whole sentence in Spanish now. I can count to 10. Okay, questions? All right, you guys still have time in here. You can work on this. Work on tooling you. Do the home quiz. Those home quizzes, you can take them. It's going to keep the best grade, so you could jump on there and take the next one before class each day. And if you don't get a good enough grade, do it with the sheet or whatever. The quizzes, it does drop the lowest 2 from the Gene M Code quizzes. So if you bomb one, don't freak out. You get 2 freebies that it'll drop off your grade at the end. Hopefully that'll light the fire for you to learn them. All right, you've all got stuff to work on, or most of you do. Get at it.